Hey guys, this is Mahesh. Today we are going to start first chapter of physics, that is units and measurements. As this is first chapter of physics of 11th science, we will also see what physics is and what science is. You are now entered into science field and you must know what exactly science is, how it works, and what exactly is scientific approaches or scientific method is. So let me tell you what is science. Science is the word which has been derived from word scientia, which is a Latin word, and which word means to know. It means to know something. Now what is that something? That something is the nature. That something is the nature. The nature around us, we always try to look at it in scientific way. Okay, and we make few theories like theory of gravitation, theory of magnetism. These are what the theories we made to understand the nature and to use all these theories, all these laws to welfare of the humanity. Let me tell you one more thing. Anything to call theory in science, that has to go through certain steps. I'll write certain steps over here. One is observation, second is experiments, third is reasoning, fourth is modeling, fifth is prediction, sixth is verification, and seventh is theory. Let's apply all these steps with one theory, that is theory of gravitation. Okay, theory of gravitation has been discovered by Sir Isaac Newton. So what Newton must have done? Newton must have observed few things, then he must did a few experiments, then he must have did quantitative and qualitative reasoning of it, then he must have made few models of it, then he must have predicted something, then he must have verified that predictions, and then that particular thing became theory. So in this way the gravitation theory came into existence. So this is how science works. Anyone have to claim any particular theory, he has to go through all these steps, and then he can claim his thing to become theory or law. That is what we call it as scientific method. And we all know that science is dynamic. Okay, why science is dynamic? Science is dynamic because there is nothing permanent theory, or there is no theory which is final in the science. So that is why science is dynamic. You can even change the gravitation theory if you go for certain observations, experiments, reasoning, modeling, prediction, verification, and then you come to know that it is going through all these steps and it is satisfying all these steps. Then you can claim your own gravitation theory, or even you can make your own laws. That is what the power of science. I hope you got exactly what science is, and then let's go towards one branch of science, that is physics. Okay, what exactly physics is? Physics is the word which has been derived from one word named physic from Greek language. So what exactly the word physic means? Physic means nature. Okay, so basically if we have to put this physics into definition, then we can define physics, the branch of science which studies the laws of nature. Okay, so that is what physics is. But physics has very vast scope in all the streams of our life. Like physics we can apply to microscopic approaches like atomic physics, nuclear physics, quantum physics. Physics we can apply for macroscopic approaches like mechanics, optics, thermodynamics, electrodynamics. Okay, so physics has very vast scope, and what exactly we get from physics, that is also one important thing. Why exactly we do study physics? The answer of this question is we get the reasoning attitude to solve the complex problems. What does it mean to solve complex problem? First of all, we have to understand the problem, then we have to split the big problem or the complex problem into simpler ones, and then we have to solve those problems. So that attitude we can get from the studying physics. So that is why we study physics. So that's all about science and physics. Now let's move towards our syllabus, units and measurements. Okay, so what exactly meaning of units? Let's see first. Units are standards of measuring physical quantities. Now what are the physical quantities? Okay, let's see that. We'll take one example for it. Let's take gravitation theory as an example. Gravitation. Okay, here is the physics and here is the nature. Okay, gravitation comes between nature and physics. Am I right? By using physics, we found out one law of nature, which is gravitation. So how exactly we communicated with nature to find out this theory of gravitation? There are the physical quantities. There are physical quantities. Okay, what are those physical quantities? The physical quantities, like, let me tell you what gravitation law is. Force between any two bodies. Suppose this is one body and this is another body. First body is having mass m1, second body is having mass m2, and suppose distance between these two bodies is d, and according to gravitation law, force of attraction between these two bodies is g m1 m2 upon d square. What does it mean by this g? G is the universal gravitational constant, which we don't have to think about. And here are the two things, that is mass of the two objects, and here is another thing, that is distance. Okay, distance nothing but length. Here are two physical quantities which we have to deal with to find out the force of attraction between any two bodies. It means in the gravitation theory we have used these two quantities. We call those quantities are physical quantities, because through which we deal with nature. Okay, through which we deal with nature. That is actually physical quantities are the language through which we communicate with the nature. So I hope guys you understood concept of physical quantities. We are going to see in next topic what are physical quantities, but for now I think this is okay. Let's go for units. Okay, now tell me what are the units? Units are standards of measurements of these physical quantities. Now what are the different systems of units? Let's see what are the different systems of units. First system of unit is MKS system. Second system of unit is CGS system of unit, and third system of unit is FPS system. FPS system we also call as British system, because this system was used in Britain. I'm going to write three physical quantities over here. One is length, another one is mass, and third one is time. If length is measured in meter, if mass is measured in kilogram, and time is measured in second, then that system becomes MKS system. What will be the CGS system? If we measure length in centimeter, if we measure mass in grams, and if we measure time in seconds, then that system will become CGS system. What will be the FPS system or British system? If we measure length in foot, if we measure mass in pounds, and time in seconds, then that system will become foot pound second system. It means FPS system. So what exactly there was need of fourth system of units, that is SI system of unit. Let's see. Suppose India is using MKS system of units, Japan is using CGS system of unit, and Britain is using FPS system of unit. Suppose scientists in India developed one theory, and that theory has to be communicated with Japan. Similarly, Britain scientists have have developed one theory that has to be communicated with Japan, and similarly Japanese scientists have also developed one theory, and that also have to be communicated with another two, and India and Japan also have to communicate between theories developed by their scientists. Then what could be the problem? You think there could be problem of communication between scientific language. It means in MKS system there are different units used. In case of CGS system there are different units used of same physical quantities I am talking about, and in case of FPS system there are different units used. So there is need to convert one unit system into another unit system, and because of that the communication will become very complex, and I will say that there will be no proper communication between two countries, between two theories. All right, so because of that there was a need of new system of units. So the new system of unit came into existence in 1971. In 1971 in France there was one general conference on weights and measures held, and in that conference it has been decided that there will be new system of units, which is system international D units. System, let me write name of it, system international D units. Actually its name was French, and this is derived English name from that French name, system international D units, and the first letters of it have been taken to call it as SI system of units. So that is what about SI system of unit, and SI system of unit is used in each country nowadays. So that is what about SI system of units. Okay, let me go ahead. Our next concept is fundamental quantities and their units. Let me tell you about fundamental quantities. Okay, now already I have told you what are the physical quantities. From those physical quantities, which physical quantities are fundamental physical quantities, that we are going to say. I will tell first of all definition of it. The quantity which do not need any other quantity to measure itself. In other words, I will say, if one quantity do not need any other quantity to measure itself, that physical quantity is called as fundamental physical quantity. For an instance, take length. Okay, to measure length, do we need other physical quantity like mass or time? Answer of this question is no. Because of that, length is called as fundamental physical quantity. Simply I can say length is independent on any other physical quantity to measure itself or to express itself. So that is why length is fundamental physical quantity. Similarly, there are more 6 fundamental physical quantities. Let me write names of it. First fundamental physical quantity is length, second is mass, third one is time, another one is temperature, next one is current, next one is luminous intensity, and last one is amount of substance. Okay, so let me tell their units also and their symbols also. Okay, length is measured in meter. It means meter is the SI unit of length, and it is shown by symbol m. The SI unit of mass is kilogram, and it is shown by symbol kg. Time, which is measured in second, and its symbol is S. Temperature, Kelvin, shown by K. Current, ampere, shown by A. Candela is the SI unit of luminous intensity, and Ca is the symbol of it. And amount of substance, mole is the unit of it, and MOL is the symbol of it. So these are all fundamental physical quantities, their units and their symbols also. All right, now let me take you to our next concept, that is derived physical quantities. Derived quantities. So what is the meaning of derived quantities? Let me tell you first of all definition of it. Derived physical quantities are those physical quantities which are dependent on any other physical quantity to express themselves or to measure themselves. For an instance, take example of velocity. What is velocity? Velocity is equal to displacement upon time. Okay, if we have to measure velocity, we must know displacement as well as time. Displacement is related to length and time. So if we know length and time, then only we can measure velocity. It means what? Velocity is the one physical quantity which is dependent on these two physical quantities. That is why velocity is the derived physical quantity. Similarly, there are lot of derived physical quantities we can say, like force, pressure, volume, area and so on. Okay, let me take you to another concept. Another concept is supplementary units. Okay, what are supplementary units? Apart from fundamental physical quantities and derived physical quantities, there are two supplementary units are provided. Two supplementary units are, one is plane angle, which is shown by symbol d theta, and second is solid angle, which is shown by symbol d omega. Okay, so these are two supplementary units provided along with fundamental and derived physical quantities. So let's see concept of plane angle and solid angle in details. Okay, so what is plane angle? We'll see first. Plane angle, its symbol is d theta. Let me draw one circle. Okay, this is the circle, this is the suppose center of circle, and let's consider 2 points on the circle. Suppose this point is P and this point is Q. Now this CP and CQ are the radii. This is R, this is R, and suppose this length is S. Now the arc PQ we can see over here, which made angle d theta with the center. So now this d theta can be defined as S upon R, as angle made by arc with center is arc length upon radius. So this angle is nothing but plane angle. So simply we can say plane angle related to the angle at a plane. This is what the plane angle. So definition of plane angle is the length to which that angle is made divided by the radius of that circle. All right, so what is unit of this plane angle? Unit of plane angle is radian, and which is shown by symbol rad. Let me tell you what exactly 1 radian is. Okay, now let's consider this arc length is equal to R. Okay, this arc length is equal to R. Then what will be the case? Let's consider this d theta as theta only. Okay, theta is equal to what? S upon R according to definition. But now in special case, what we have taken, this S is equal to R, it means R upon R. So R will get cancelled, so theta will become 1 radian. So this is the definition of 1 radian. Theta is equal to 1 radian when the arc length equal to radius of the circle makes angle to the center, then that angle will be 1 radian. That is what the concept of 1 radian, and it is very important to understand the concept of 1 radian because many people don't know what is 1 radian. Okay, so now let's explore one more concept over here. As we have taken this arc length, what is the arc length? Arc length over here is S is equal to R. If we take total circumference as arc length, if we take total circumference as the arc length, how much will be the angle made by that arc with the center of the circle? That angle will be 360 degree. Am I right? So let's put our formula. The angle made by arc to the center is equal to arc length upon radius. Am I right? So theta is 360 in this case is equal to 2 pi. This r will get cancelled, so theta is equal to 2 pi. Simply we'll say 360 degree is equal to 2 pi radian, or we can say pi is equal to 360 divided by 2, so pi radian is equal to 180 degree. So that is the relation between degree and radian. Over here we can see one more concept is relation between radian and degrees. What is relation between radian and degree? 1 radian is equal to 180 divided by pi degrees. If you have to convert 1 degree into radian, then it will be pi by 180 radian. So that is what relation between degree and radian and degree. I hope this concept is clear to you guys. Let's go towards new concept, that is solid angle. Okay, its symbol is d omega. Now try to understand, plane angle was related to shape on a plane, but solid angle is related to body in 3 dimension. Suppose we consider one part of the sphere A, B, C and D. Suppose I take this part of a sphere, so part of sphere will be area, of course. Suppose this area is dA and this is the center. Let's join all the points with centers. Okay, so as I told you, this ABCD is the small area which is part of total surface area of the sphere, and this O is the center of the sphere. Now as I said, solid angle will be the angle between all these 4 sides, so d omega will be the solid angle over here, and this, suppose r is the radius. Now according to definition, what is solid angle? Solid angle is the area subtended to the part of sphere divided by radius square. So that is nothing but the solid angle, and unit of it is steradian, and simply we can show it by SR. That is what the concept of solid angle. I hope guys this is also clear to you. Now let's move towards another topic, that is conventions for use of SI units. Conventions for use of SI units. What are the different conventions for using SI units that we are going to see? Okay, so first convention is representation. We have to represent any SI unit by its symbol, like Newton is the symbol for unit Newton, which is the SI unit of force. Meter is the symbol of meter, which is a unit of length. Like this we have to represent the units. Second convention is full name should start with small letter, even if it is name of any scientist. Like for an example we take Newton should be the name of unit, not Newton. Okay, or one more example I can give you, Kelvin should be the name of unit, not Kelvin. I hope guys second convention is also clear to you. Third convention is no plural form. No plural form. It means what? We can't say that I have 10 meters of string. 10 meters. We can't say 10 meters. We have to say 10 meter. So that is the correct convention. Now the fourth convention is no full stop. What does it mean by no full stop? After any unit we should not give any full stop. It means what? After the symbol, if we are giving full stop, that doesn't come under convection. We should avoid this practice to put full stop after the any symbol of unit. Suppose one sentence is ending with one symbol, at that time you can give full stop, but immediately after symbol, in between symbol is coming, then you can't give any full stop. That is what the fourth convention. Now let's see fifth convention. Fifth convention is about ratio. Okay, if there is ratio of two units, let's take example of acceleration. For acceleration, what is the unit? Acceleration is velocity upon time, and unit of velocity is meter per second, and unit of time is second. So here second comes two times, so meter per second divided by second. This should not be the unit. What should be the unit? Meter per second square, or meter hyphen second raised to minus 2. That should be the method of writing, not this. Okay. Sixth, combination. Okay, if there are two units in combination, Newton per meter square, suppose for an example, which is unit of pressure. Okay, here there should not be Newton per meter square, or there should not be like Newton per square meter. Okay, these are the wrong methods of showing units. This is the correct convention to show the unit in combination. Let's go for seventh one. Seventh one is prefix. So what does it mean by prefix? We have to keep we have to put one letter before unit. It means what? Let's take example of second. Before second, if I put m, then it means millisecond, and which is equal to, and 1 millisecond is equal to 10 raised to minus 3 second. Let's take another example. If I put micrometer, then what does it mean? Micrometer, which is equal to 10 raised to minus 6 meter. So this prefix changes the meaning of the unit. Now go for last one, that is we have to put space or hyphen between two symbols. Okay, let's take an example. Newton meter. We should not write it like Newton meter. We have to write it like Newton space meter or Newton hyphen meter. Or one more example I can take, velocity, meter per second. I should write it like meter hyphen second raised to minus 1, or I can write meter second raised to minus 1. I should not write it like meter second raised to minus 1. It will look like milliseconds. Okay, so we should avoid such a practice. Alright, I hope guys conventions for writing units are also clear to you. Let's move towards another topic. New topic is measurement of length. Unit of length is meter. Okay, so how exactly this meter has been defined? In 1960 it has been decided that the wavelength of orange red light coming out from atoms of krypton is 1 meter. Let me tell once again definition of meter. 1 meter is nothing but the wavelength of the orange red light coming out from atoms of krypton, which was in use from 1960. But in 1983 that definition has been changed. The new definition has been adapted. I can say new precise definition has been adapted. What was that precise definition? 1 meter is the distance traveled by light in vacuum in 1 upon 299792458 second. It means what? In that much amount of time, whatever the distance light ray covers in vacuum, that distance is called as 1 meter, and this is what the speed of light in vacuum. Generally we take it as 3 into 10 raised to 8 meter per second. Okay, so that is what about measurement of length. Let me give you variation in length. Okay, let's take first example, distance of Andromeda galaxy from Earth. This distance is 2 into 10 raised to 22 meters. Second, Earth radius is how much? 6.4 into 10 raised to 6 meters. Third one is diameter of coronavirus is 1.25 into 10 raised to minus 7 meter. And last example I am taking over here, diameter of proton is 2 into 10 raised to 15 meters. So you can see how huge difference between the minimum length I took over here, and this is minus. How big difference between Andromeda galaxy distance from Earth and diameter of the proton. So we have to measure very large distances as well as we have to measure very small distances. So let's see how large distances we can measure. For that purpose there is one method named Parallax method. Okay, let me tell you meaning of this word first, parallax. For that purpose you need to do one experiment. You have to put one finger in between your eyes and the object in front of your wall, and first of all you need to close your one eye and you need to see that object by second eye, and in second step you need to close your second eye and you need to see object by first eye. Then you must observe that there is change in the position of the object. So that change in the position of the object is nothing but parallax. Okay, so what happens, let's figure out what exactly we have did. Here is the object on opposite wall of you, and here are your two eyes. This is I1 and this is I2. Let's draw the lines. Okay, so this is the angle. This angle is called as parallax angle. Parallax angle. As our eyes make angle with the object, that angle is parallax angle. Suppose distance between two eyes is small d, distance between eyes and that object is d. Then we can find out distance between eyes and object. How we can find out? Let's put one formula. Angle is equal to arc length upon radius. As this is a small distance and we can treat as a part of circle of which radius is this distance. Okay, and according to this d is equal to d upon theta. So in this manner we can find out this distance. We can apply same concept with same concept for measurement of distance of stars and planets from the Earth. So let's say how we measure distance of planet from the Earth. Let's consider this is Earth, and here there are 2 points on Earth. Suppose these points are A and B. This is Earth, and here is the planet, suppose Jupiter. Okay, now what we have to do? We have to measure the distance between Jupiter and Earth. Here is the angle theta, which is called as parallax angle, and this is the supposed distance between 2 points on Earth, which we can measure easily. And here is the Jupiter. This angle is parallax angle, and suppose this this point is J, this is D, the distance between Earth and Jupiter. That distance we have to measure. We know this distance and we know the angle. Now how to apply this method? Same formula you have to use, but over here we have to understand one thing, as this distance is very small than the distance between Earth and Jupiter. The distance between Earth and Jupiter in millions of kilometers and this in thousands of kilometers. So of course this D is much higher than this D. So this D we can take as arc of the big circle, of which this D is the radius. So that's why we can apply one concept, theta is equal to D upon D, and therefore this distance between Jupiter and Earth is equal to D upon theta. So simply we have to apply this formula and we have to find the distance between two planets. So that's it. That is called as use of parallax method for measurement of distance between Earth and planet. This parallax method also can be used to measure the distance between Earth and stars, but keep in mind stars are very far distance from the Earth. Nearest star we know is Alpha Centauri, which is, this is suppose Earth, and distance between star Alpha Centauri and Earth is 4.37 light years. What exactly meaning of distance 4.37 light years? I will tell you. Alpha Centauri is the nearby star to Earth after Sun. Sun is over here suppose, and Alpha Centauri is at that much distance, which is Sun and Earth distance is only 15 crore kilometer, and this distance is 4.37 light years. As you need to understand what is 1 light year. 1 light year. How much is the distance covered by light in 1 second? 3 lakh kilometer is the distance covered by light in 1 second. Now how much distance that light will cover in 1 minute? 3 lakh into 60. Again if we do into 60, then it will be the distance covered by light in 1 hour. Then again we can multiply it by 24, that will be the distance covered by light in 1 day. Again if we multiply it by 30, then it will come the distance covered by light year in 1 month, and if we multiply it by 12, then this will give us the distance covered by light in 1 year. So it will be in kilometers. You can just imagine how big digit it will be, and that is what the distance covered by light in 1 complete year. Alright, so 1 light year is that big digit. So you can just imagine how big distance between Earth and the nearby star to us after Sun. So we can't measure the distance between Earth and star by using our conventional parallax method. For that purpose we have to do one thing. Suppose this is the Sun and this is the Earth. Suppose this is Alpha Centauri star, Alpha Centauri. This distance we have to measure. We can take one point on Earth over here, and when Earth goes to another side of Sun after 6 months, this is E2 position and this is E1 position, and then we can make one angle with the star, and this angle is the theta. This distance we can take as small d, this distance we can take as capital D, and again as d is very smaller than the d, we can apply formula theta is equal to d upon d, and d is equal to the distance between Earth and star is equal to d upon theta. So by this way we can measure this huge distance between Earth and star. The nearby star is Alpha Centauri, as I told you, which is only 4.37 light years away from us, and if we look at the other stars, they are far away than that also. This method is useful to measure the distance of stars from the earth. Alright, I hope guys this is also clear to you. Okay guys, that's all about first part of units and measurements. We'll see rest of the things in next part. Please feel free to ask questions in the comment box. I will try to answer most of those. If you found this lecture useful, please subscribe to this channel. See you in the next lecture.